Refining the response. Building a gaming PC is like tuning a race car. Pick the right parts, verify compatibility, and plan a clear build process before you touch any screws. Key components are CPU, GPU, motherboard, RAM, storage, PSU, and case. Each choice affects performance, thermals, and future upgrades. During assembly, work on a grounded surface. Install the CPU and cooler. Seat RAM. Mount the motherboard, fit the GPU, and route power and data cables neatly. On first power up, enter BIOS to confirm components and enable XMP if needed, then install the OS and drivers. Finish with thorough testing. Run stress tests, monitor temperatures, and tune fans and power settings for stable gaming performance. I am resolving the signal. Think of the parts like a small team inside a car. The CPU and GPU are the brain and engine. They decide and render the games. The motherboard is the chassis that connects everything. RAM and storage are short-term memory and the garage where you keep your games. The PSU and cooling supply steady, clean power and temperature control. And the case and assembly are the physical home and how you put it all together. For a gamer, prioritize GPU performance. Balance the CPU to avoid bottlenecks. Match parts to a compatible motherboard. Pick RAM and storage for speed and space. Size the PSU with headroom. And choose cooling and a case that fit your noise and airflow goals. Click any area to dig deeper. CPU and GPU. Motherboard, RAM and storage. PSU and cooling. Case and assembly. Refining the response. Think of the CPU as the brain of your gaming PC and the GPU as its artist. The CPU decides game logic, AI, and physics, while the GPU paints frames fast with shaders and textures. Together they determine smoothness and responsiveness. When building a gaming PC, pick a CPU and GPU that match the games you play, and check motherboard socket, CPU cooler clearance, and how much RAM the GPU has. Budget, power supply capacity, and case airflow all matter, but start by matching performance to your target resolution and frame rate. One moment, the answer is forming. When you're building a gaming PC, parts includes a CPU and GPU, and choosing a GPU is like picking the right paintbrush for the picture you want. The GPU renders frames and effects, the CPU feeds it data. A good match avoids bottlenecks and wasted money. Start by deciding your target resolution and frame rate so you know the level of muscle you need. Pick the right RAM for your textures and resolution. Decide if ray tracing and special features matter, and factor in power, cooling, physical size, and motherboard/PSU compatibility. Finally, Balance budget versus how long you want the card to stay relevant. Interpreting your request. Think of cooling and airflow as the way your case breathes. This is the cooling and airflow subtopic of CPU and GPU, which lives under parts and how to build a gaming PC. Picture air as a river. You want a steady intake at the front/bottom, a clear channel past the CPU and GPU, and exhaust at the top/rear so heat doesn't stagnate. Good airflow reduces fan speed, lowers temperatures, and keeps components lasting longer. Start by learning airflow basics: intake vs exhaust, positive/negative pressure, then match fan types to rolls, static pressure for radiators, high airflow for case vents. Choose CPU coolers or GPU cooling solutions that fit your case. Use the right thermal paste and mounting technique, and tune fan curves in software so fans only spin up when needed. Click into airflow basics, CPU coolers, tracing the contours of an answer. GPU cooling is about letting the card move heat away fast enough that it doesn't slow down. The main choices: cooler types determine whether heat is exhausted out the back of the case, spread across a big heatsink, or sent into a water loop. Good GPU cooling reduces throttling, controls noise, and makes overclocking safer. Also keep the whole case in mind. Airflow basics let that heat leave the case instead of recirculating around components. Practical steps: arrange intake and exhaust so the card has a clear path. Pay attention to case layout, and use gentle fan tuning to meet a temperature target without excess noise. Regular maintenance: cleaning dust, checking thermal pads/paste, and simple monitoring are what keep your cooling effective over time. Click any topic below to dig into specifics.